This is the Geometry Chapter 5 Final Review. This chapter we talked a lot about properties of different lines and different points that are created. So we talked about midsegments, perpendicular bisectors, angle bisectors, medians, altitudes, and then we started to write some proofs. And we talked about the inequalities involving angles and sides of triangles. And then we applied inequalities in two triangles. So this one's going to be pretty short, just 3 slides, but some important stuff in here. So we're going to start off with talking about properties of midsegments and using them to solve problems. So first off, what is a midsegment? It says, what are 3 parallel segments in triangle BEL? What a midsegment is, if you look in this picture, a midsegment is a segment that connects 2 midpoints. So like MP right here is a midsegment. And the cool thing about that midsegment in a triangle is that that midsegment is actually parallel to the side across from it. So the side is not part of it. So I can actually say that MP is parallel to EL right off the bat. So when you write this, remember when you name a segment, you put that little parallel bar, you put that little bar above it for segment, and then is parallel to EL. And you want to line up the corresponding parts as well as you can. So there's one pair of parallel segments. There's actually 2 more, so why don't you pause the video and see if you can identify the other 2. Right, there are your other 2 pairs. NP is parallel to EB and MN is parallel to BL. So after that, we kind of started to build off of, well, there's a ton of parallel things in here, like the greens are parallel, the blues are parallel, the reds are parallel. And we started off by giving an angle measure. So angle B is going to be 52 degrees, right here. What's the measure of angle NME? So remember, when you find an angle, you trace the point. So N to M to E. Well, that's this angle centered here at M. Well, if you think about it, MN is parallel to BL. So you've got a parallel line here and a parallel line there. What's the relationship between these 2 marked angles? They're corresponding angles. And we talked about this way back in chapter 3, but corresponding angles are congruent. So the measure of angle NME is just going to be the exact same thing. And we could actually use that to help us find a bunch of different angle measures in this picture if we had a few more, which is kind of a cool thing. So after that, we really focused more on midsegments and midpoints. Here, you can see it's a similar picture. It says in triangle LAN, ER, and S are midpoints. What are the lengths of RS, ES, and LN? So we're trying to find RS. That's right here. We're trying to find ES, right, in blue. And we're trying to find LN. It's down here in red. Okay. So, much like we had all those angle and parallel relationships, we have some measurement relationships as well. So like if we have a side AL, it's 50 units long. Well, the midpoint E cuts that in half, so you have a chunk of 25 and a chunk of 25. And that midsegment is half as long as the side. So if the side is 50 and we've got 2 25 chunks, we've got another 25 chunk over here at RS. And we can kind of go that way and break through and find these other parts once you pause the video and try to find ES and LN on your own. Alright, you can check your answers with mine. RS was 25, we did that one. ES is 20 and LN is 60. Okay. So that was kind of your midsegment stuff. After that, we kind of talked about properties, perpendicular bisectors and angle bisectors. It says, what's the length of CB? Well, right here, what we have in the middle of this triangle, from C down to that midpoint, let's call this point M, we have a perpendicular bisector. And the cool thing about a perpendicular bisector like that is this actually results in an isosceles triangle where these 2 parts are going to be the same length. So if we're trying to find CB, we need to know x. And 8x minus 6 is the same as 6x minus 2. So we can go find x to go find CB. We just start to solve. I get 2x minus 6 equals negative 2. I add 6. 2x equals 4. I get x equals 2. But that's not what the question was. It says, how long is CB? So I go take that 2, plug it in. 8 times 2 minus 6. That's 16 minus 6, which is 10. CB equals 10. So it's kind of some of these relationships going on. On this next one, they use it a little bit differently. It says, what is the length of RM you can see that actually RM is an angle bisector. I think that's a typo. That's supposed to say RN. Let's fix that. So we're trying to find RN right here. But you can see that RM here in the middle is an angle bisector because of these two congruent parts. Well, the cool thing is that when you have an angle bisector like that, these perpendicular distances from the side are going to be the same again. So we can now set up an equation and we can solve for x again. I subtract 6x, subtract 6x, 2x is 10, divide both sides by 2 and I get x equal to 5. Once again, that's not what we're looking for our answer. We're trying to find that Rn. So Rn is 8 times 5 plus 10, or sorry, 6 times 5 plus 10. So go plug that in. And we get 30 plus 10, which is 40. Rn equals 40. Okay, so you can kind of see some of the stuff that's going on here. Lots of congruent parts are created. After that, we talked about identifying properties of medians and altitudes of triangles. It says in the diagram at the right, XA is 10. So I'd go find that. This is XA, that's 10. What is XB, this entire segment? Okay, if you look at that, X is a vertex of the triangle and B is a midpoint. So actually this blue line is referred to as a median. It goes from a vertex to a midpoint. And the cool thing about a median is actually when you have other medians, which you do, like YA and CZ, they create this point called the centroid. It's the center of gravity. You can balance any triangle on the centroid. And what happens is it actually cuts these segments into chunks. So you've got 2/3 of the set median from the vertex to the midpoint and another 1/3 from the midpoint to the side. But the way that I like to kind of think about it is this part right here is double what I have over there. So well, if this is 10, it's double what was over there, so I want to take half of it. Well, over there is 5. So then the whole thing is 10 plus 5, 15. XB is then 15. And so there's a lot of these relationships going on in these triangles. There's similar stuff going on. We'll talk about a little bit more in a moment, but we're just going to identify what type of a segment we have. Here it says, for triangle PQS, is QT a median and altitude or neither? Explain. So I look Q to T is this segment right here. It goes from a vertex to a midpoint. That sounds really familiar. It's what we just talked about. That's a median. To explain, I just explain where the endpoints are, what I just said. Vertex to midpoint. Now remember that an altitude is how tall a triangle is. The altitude in this particular picture could be PR or RQ. It goes from a vertex and makes a right angle kind of opposite it. So those would both be altitudes in this one. So what you're looking for in this last picture is to identify each segment as a median, an altitude, or neither. I just talked about what a median was and what an altitude was. So pause the video and see if you can come up with what these ones are. Alright, you can check your answers with mine. AD is a median. It goes from a vertex A to a midpoint D. EG is actually neither. E is a midpoint, but G is not anything special. We don't know anything about it, so we can't call that one anything. CF is C is a vertex and F is a point that makes a right angle with the opposite side there, so that would be an altitude. And that's actually everything in chapter 5 that we need to go over today. That was your geometry, chapter 5 review for the final.